In the ongoing investigation of the universe, astronomers have come across a development that has reignited widespread interest. A space-based telescope has detected compelling visual data radiant glows appearing to stem from a specific point in the cosmos. These illuminations resemble the nighttime appearance of a city viewed from above, a pattern both familiar and mysterious. What's especially intriguing is the proximity of the source, approximately 4 light-years away. This enigmatic light has stirred renewed fascination among scientists and the public alike, rekindling discussions around the existence of intelligent life beyond Earth. This discovery has redirected focus toward Proxima Centauri b, the nearest exoplanet to our solar system. Orbiting within the potentially habitable zone of the red dwarf star Proxima Centauri, the planet has become a primary candidate for deeper study. Observational equipment recorded bursts of light radiating from the planet's location, prompting a surge of questions and hypotheses. Could these flashes be manufactured? Might they be evidence of alien engineering or activity? Though speculative, such inquiries are grounded in a long-standing human interest in the possibility of life elsewhere in the cosmos. Each new piece of information that suggests life beyond Earth is met with a blend of anticipation and caution. A major turning point in the search for extraterrestrial life came with the operational launch of an advanced infrared telescope in 2022. Its ability to capture data at wavelengths previously inaccessible to older instruments has enabled scientists to uncover patterns and anomalies across deep space. During observations of Proxima Centauri b, the telescope identified unusual heat signatures and light fluctuations that bear similarities to those produced by artificial lighting on Earth. This raised the profound possibility that these could represent energy consumption or infrastructure of a kind potentially built by non-human intelligence. Although entirely hypothetical, the idea has captured the attention of researchers from multiple fields. The possibility that intelligent life could inhabit Proxima Centauri b and that it might be capable of constructing large-scale structures has profound implications. Confirmation of such a presence would constitute one of the most significant scientific breakthroughs ever recorded. Experts speculate that what is being observed might mirror our own techniques of nighttime illumination, albeit influenced by an alien environment and evolutionary path. Researchers such as Columbia University's David Kipping have emphasized the planet's complex environmental conditions. Unlike many rocky worlds that merely remit the light from their stars as heat, Proxima b shows a distinctive energy footprint. This is likely influenced by its dynamic thermal and orbital interaction with its host star, known for powerful flares and magnetic disturbances. These characteristics make the exoplanet an especially intriguing object of study. The telescope's high sensitivity to infrared wavelengths, those invisible to human eyes, provides vital data about surface temperatures and chemical composition. It was this capability that enabled the detection of light anomalies on the planet's night side, where any source of artificial illumination would be most noticeable against the surrounding darkness. The telescope is finely tuned to pick up even faint signals that older instruments would likely miss, making it well suited for determining whether such glows might have an unnatural cause. Proxima Centauri b follows a tight orbit around its star, completing a full revolution in just over 11 Earth days. This close proximity causes stark variations in how much stellar radiation it receives, creating intense contrasts between its dayside and night side. If the planet lacks a significant atmosphere or oceans to moderate these extremes, daytime temperatures could become scorching, while the opposite side plunges into deep cold. Scientists are particularly interested in these temperature differences, as they offer insight into the composition and behavior of any atmosphere the planet may possess. Without a protective atmospheric layer to redistribute heat, surface conditions would be highly variable. Through ongoing monitoring of these patterns, researchers aim to understand more about Proxima b's potential to host life. Should an atmosphere be confirmed, the next critical step is analyzing its chemical makeup scientists are looking for biosignatures, gases like oxygen, methane, and water vapor that on Earth are linked to biological processes. These molecules, especially when found in particular ratios, could indicate the presence of life-sustaining environments. To detect these substances, astronomers study the way light from the host star passes through the planet's atmosphere during transits, a technically demanding procedure. The current telescope is especially good at identifying elements, such as carbon dioxide and methane, though it's less adept at finding free oxygen, a key biological marker. However, it can detect ozone, which serves as a secondary indicator of oxygen-rich conditions. These analyses help determine whether the planet's atmospheric chemistry could stem from purely geological sources or possibly biological ones. It's worth acknowledging that even the most advanced telescopes face observational limitations. Their reach is mostly confined to nearby planetary systems, making it difficult to study more remote worlds in detail. As a result, scientists are eagerly awaiting the next generation of observational tools. One such project is a massive ground-based observatory slated for activation in 2028. This facility will provide astronomers with enhanced capability to examine exoplanetary atmospheres, offering deeper insights into the presence of life beyond Earth. Meanwhile, research continues into technologies that can help detect and analyze exoplanets more effectively. One major obstacle is the overwhelming brightness of stars, which tends to obscure the faint light reflected from nearby planets. To counter this, engineers are developing instruments known as coronagraphs. These devices filter out starlight inside the telescope, allowing dim planetary signals to emerge. By reshaping incoming light waves, coronagraphs reduce glare and make faint celestial bodies more visible. Another promising innovation is the Starshade, an enormous spacecraft with petal-like structures designed to block starlight before it reaches the telescope. Positioned tens of thousands of kilometers away, the Starshade works in tandem with a space telescope to ensure that only planetary light enters its lens. This method could drastically improve the study of planets located in their star's habitable zones, where conditions might support liquid water and, potentially, life. However, the engineering demands are immense. A starshade must stay precisely aligned within millimeters over vast distances to function effectively. It also has to be compact, energy efficient, and durable enough to endure the harsh environment of space. Despite these technical challenges, the scientific potential is enormous. Successfully identifying signs of biological activity could ultimately prove that life exists elsewhere in the universe. Looking even further ahead, scientists hope to go beyond detecting biosignatures and actually capture images of distant planets in detail. This would allow researchers to map surfaces, study climate systems, and identify geological structures. Future telescopes may employ adaptive optics to correct for atmospheric distortions, further improving image quality. When combined with light-blocking technologies, such advances could dramatically expand our ability to explore alien worlds. The creation of next-generation space observatories represents a crucial leap in addressing one of humanity's most enduring questions. Are we alone? As we enhance our capacity to observe distant systems, analyze planetary atmospheres, and interpret subtle clues in the data, we inch closer to an answer. Should we find signs of life or even civilizations, it would transform our understanding of our place in the cosmos and rewrite the story of existence itself.